Welcome to Math 8 YouTube version. Today we're going to be looking at 2.2, which is lines on a plane. Let's jump right in with the definition. So first we'll examine the slope of a line. The slope of a line is a measure of the steepness of a line. The slope shows how much a line rises compared to how much it runs. For the slope, we use the variable m. Now all we need to find the slope is 2 points. So if we want to know the slope of a line passing through 2 points, just like last class, we'll call them x1, y1 for the first point, and x2, y2 for the second point. Then all we need is the equation for slope. The slope just tells you how much the y values change compared to how much the x values change. And again, just like last class, it doesn't matter which order you put the points, which point comes first, which point comes second, as long as x1 and x2 refer to one point and y1 and y2 refer to another point. Another way that we can say this is that it's just saying how much the line is rising, how much the y values are changing, compared to how much the line is running, which is how much the x values are changing. So if we just draw a little sketch on the side here, if I'm given any old random point, let's say that this one is my x1 and y1, and let's say that this one is my x2 and y2, the slope is just telling me how steep this line is. So let's look at an example. Find the slope of the line through the following points. We'll do a couple different pairs of points. So for part A, let's take a look at the slope through the points -2, 0 and 3, 1. Okay, so again, it doesn't matter which points we call x1, y1, x2, y2. We'll just call the first ones x1 and y1, and the second point x2 and y2. So the equation for slope is just how much do the y values change divided by how much do the x values change. So from y2 to y1, we've got 1 minus 0. From x2 to x1, we have 3 minus -2. So 1 minus 0 is 1. 3 minus -2 is 5. So the slope is the number 1 over 5. Now let's just take a look at what this looks like on a graph. So here's my y-axis and my x-axis. So I have the point -2, 0, which is right here, and 1, 2, 3, 1, which is right here. So the slope of this line through those points Now, one way to visualize the slope is just pretend that you're walking along that line. And as you're walking, you're always walking from left to right. Okay, is it very hard to walk up that hill? Probably not. It's not so fun to skateboard along it. It wouldn't be such a great ramp. It's not too hard to walk around it. So what we're going to do is we're going to say that this is a small slope. We're also going to say that it's a positive slope because we're heading uphill on that line. So this is a small positive slope. And you can see that the rise tells you how much the y values are changing. So another word for this number here is the rise. That tells you how much you go up if you're going to make a triangle out of those 2 points, compared to the run. The run tells you how much you have to go across if you're going to make a triangle out of those points. So we have to go across 5, up 1, so the slope is up 1 over 5. Now what about through the points -1, 2, and 2, 2? Okay, let's call the first ones x1, y1, second one's x2, y2, and let's just find the equation, which is just saying what's the change of the y values compared to the change of the x values. So y goes from 2 to 2. It doesn't change at all. X goes from 2 to -1. So 2 minus 2 is 0. 2 minus -1 is 3. So we have 0 divided by 3. I'm taking out my handy calculator. 0 divided by 3 is 0. Okay, so my slope is 0. What does that really mean? Let's take a look at the graph. Okay, so I'm starting from the point -1, 2. I'm going to the point 2, 2. And if I walk along this line between those 2 points, then there's no slope to that line at all. The ground is flat. We call this 0 slope. It's not such a fun mountain to ski down. There's no slope to that line. Okay, so we can also see that this line does not rise at all. It only runs across 3. Okay, third example. What about the slope through the point 0, 4 and 1, -1? Okay, let's calculate it first. So the slope is how much do the y values change compared to how much do the x values change. 1 minus -1 minus 4 is -5. 1 minus 0 is 1. So this slope is -5. Let's take a look at the graph. If we plot those points, we get the point 0, 4 and 1, -1. When you connect those two lines, those 2 points, if you're going to walk along that graph from left to right this way, what happens is that you're going downhill. The rise is negative, which means that to go from one point to the other, you have to actually go down 5, while the run is positive. So go across 1. Okay, that's a pretty steep slope. If you imagine skiing down a hill like that, we call this slope a large negative slope. So the negative shows that you're going downhill. The large number tells you that it's really steep. So 5 is a really large number when it comes to slope. In order to get a small slope, you have to have a number like 1 over 5. 1 over 5 is a number 0.2. It's a number that's less than 1. So numbers that are less than 1 give you pretty small slopes, whereas numbers that are bigger than 1 give you pretty big slopes. What about if I'm given the points 3, 4 and 3, 1? Okay, so the slope is how much do the y values change compared to how much do the x values change. So 1 minus 4 is a -3. 3 minus 3 is 0. Let's try that on the calculator. -3 divided by 0 is undefined. You cannot divide by 0. This gives you an error. There's no real number. Whenever you divide by 0, you get an error. We can also call this infinity, because when you divide by really small numbers, the answer is really big. Let's take a look at what it looks like on the graphs. So we've got the point 3, 4, and 3, 1. If we connect those dots, now imagine trying to walk along a line like that. You're totally going to fall off. Okay, it's so steep that we say it's infinitely steep. So in general, you can have several slopes. Okay, so a line could be positive slope. What a positive slope means is that as you're going from left to right, you're going uphill. So this would be a big positive slope, and this would be a small positive slope. Okay, you can also have negative slopes, which means that as you're going from left to right, you're going downhill. So this would be a large negative slope. And this one would be a small negative slope. You can have, very importantly, no slope at all. That means the ground is just flat. Or you can have an undefined slope. Undefined slope is the same as an infinite slope, which means that you can't walk along it at all. This slope is infinity. We can also call this slope undefined. Now, if you know the slope of a line, and a point on the line, you can find the equation for the line. Using something that's called point-slope form. Okay, and the point-slope form of a line is just y minus y1 is equal to m times x minus x1. And what we're going to be doing is we're going to be plugging in a number for m, and we're going to be plugging in a point for y1 and x1. And we're going to leave x and y as variables. By the way, this just comes from the slope formula. Okay, how does it come from the slope formula? Well, the slope formula said that if we took y2 minus y1 over x2 minus x1, that gives us a slope. Now, if I just take this part of the equation and I move it over to the other side, if I get rid of the fraction by multiplying it to the other side, then I pretty much just get this slope form. But I only have 1 point, so I'm just going to erase the 2's. So I only have 1 point. So that's where this point-slope formula comes from. So let's look at an example. Find the equation of a line through the point 1, negative 2 with slope of 3. Okay, so using the point slope form, I've got y minus y1 equals m x minus x1. So all I have to do is figure out what is the slope. Well, it tells me the slope is 3. So m stands for the slope. Then I got to figure out what's my point. Well, my point is just, here's my x coordinate, and here's my y-coordinate. I'm just going to plug in those things. So here's my x1 and y1, and here is my m. M stands for slope. So I put in -2 for y1, 3 for m, and I get y plus 2 is equal to 3x minus 1. And that's my solution. I don't have to expand. I don't have to get y on one side by itself. I can leave my answer in that form. There's an equation for a line given a point and a slope. Let's do another one of the similar nature. Find the equation of a line through the point -8, -3 with a slope of 3/2. Okay, so again, I know my slope and I know my point. So what I can do is just take the point slope formula for a line, which tells me that y minus y1 equals mx minus x1. So instead of y1, I'll put my y-coordinate on my first point. Instead of m, I'll put the slope, 3/2. Instead of x1, I'll put the x-coordinate on my first point, -8. And I get y plus 3 equals 3/2 times x plus 8. And that's my answer. There's an equation of a line that has a slope of 3/2 and goes through the points -3, -8. Now the trouble is, usually when we're trying to make a table of values or a graph, we're going to get y on one side by itself. So one of the things that we could do with this equation is we could expand this through, and we could try to get y on one side by itself. So let's see if we just change the form of this equation. 3/2 times x, and then 3 times 8 is 24, divided by 2 is 12. Now I can move the 3 to the other side. And I get y equals 3/2x plus 9. This is another way of writing the same line. Now what happens if I graph that line? So there's my x-axis, my y-axis. Okay, so I know I want to go through the point -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So there's my point -8, -3. And I know my slope should be 3/2, which means I should rise 3 and run 2. So I'm going to rise 3 and run 2. When I go up 3 and across 2, then I get my next point. I can continue that process. Up 3/2, up 3/2, up 3/2, and it'll give me all the points that are on the line. And if I connect the dots, then that gives me the line. So both of these equations will give me the same line. If I make a table of values with both of those equations, I'm going to get the same information. And you can see that these equations have a lot in common. They both have the 3/2. And the 3/2 is just the fact that you can go up 3 over 2 to get to any point on the line. Now, the point slope form shows me that the point goes through 8, 3. So the fact that it goes through the point 8, 3 is in this first form, which is called point slope form. So the only question is, what does this 9 represent in the second form of the line? Now, if we just count out here, 1, 2, 3, 4, 5, 6, 7, 8, 9, you'll see that this graph crosses the y-axis at the point 9. So this 9 represents where the graph crosses the y-axis. And this leads us to the second form of the line, which is called slope-intercept form. And we'll continue this